IPv6 is what we did in our last class. Every other thing left here is just story. Yes, I have started recording. Thank you, Samuel. You always reminded me. And I've muted everybody. Thank you. So the most important thing about IPv6 is what we did in our last class on IPv6. Understanding the concept, how to read it and all of that. But we have a few more things to add to. So let me check. Yeah, we have a few more things to add to IPv6. So let's just go through it. IPv6 address types. When you hear about IPv6, you can also put them under categories. Just like in IPv4, we talk about Unicast. We also have Unicast in IPv6. In IPv4, we talk about Multicast. We also have Multicast in IPv6. They are the same thing. The only difference is Anycast. In IPv4, we don't have Anycast, but in IPv6, there is Anycast. So what is Anycast? Now, let me say, for emphasis sake, or just like a revision, Unicast, of course, you guys know is one-to-one communication. Multicast is one to a group of people. Broadcast is one to everybody. You know that already. But now, here we are with Anycast. So what is Anycast? Anycast is a new concept completely under IPv6. We don't have this under IP version 4. This is any IPv6 Unicast address. Take note, that can be assigned to multiple devices. Oh, that can never happen on IPv4. One Unicast address being assigned to multiple devices. That can never happen on IPv4. It's like having 2 systems, 4 systems, 5 computers, 6 computers, servers, having one IPv6 address. It can only happen in IPv6. It can't happen in IPv4. Because if you try that in IPv4, the computers, they will start telling you IP conflict, IP conflict, IP conflict, IP conflict. But there is a reason why they brought this up in IP version 6. And the reason why they brought it up in IP version 6 is, look at the reason here. A packet sent to Anycast address is routed to the nearest device having that address. It's like now, I want to go to Google. There's a Google server in let's say, Lokoja. Or let me talk, since we have international people from different countries. There's a Google server in London. There's a Google server in France. There's a Google server in South Africa. And all these Google servers have just one IPv6 Unicast address, all of them. So if I want to go to Google now, the moment I place demand on that domain name, before it is the result to an IP address, which of those servers will answer to me? It is the one that is the closest to my destination, or to where I am, that will respond, because it's like I am calling 3 different servers with the same name, with the same IP address. Only one of them will respond. So who's going to respond first? It is the closest one to me that will respond. So why will it be that it is the closest one that will respond to me? Because that it makes sense. That will reduce the latency. It will reduce delay. So they know that, okay, between me and that particular server is the closest to me. It only makes sense for that one to reply to me. So this is a new concept entirely. It's a complete new, something that is completely new in IPv6. So when you hear Anycast, it is also an IPv6 Unicast address that can be assigned to multiple devices. It can be assigned to multiple devices, and there will be no problem. There will be no complaint. If you try this in IPv4, there will be complaint. In IPv6, no complaint, no fight, no quarrel. It will work. It's a new concept. So take note of that. All right. Unlike IPv4, now look at it here. IPv6 does not have a broadcast address. So there's nothing like broadcast in IPv6. But there's a similar concept. The behavior looks like broadcast as well. We don't call it broadcast. However, there is an IPv6 all nodes multicast address. See, do you see that? All nodes, IPv6 all node multicast address that essentially gives the same result. As far as I'm concerned, they just change the name. The behavior is the same. All nodes multicast address is the same thing. But they told us we don't have broadcast address. So they know better than us. They know why they didn't call it broadcast. So let's just agree with them. We don't have a choice. We have to agree with them. So under IPv6, take note of these address types. You have unicast, IPv6 address. You have multicast, IPv6 address. You have anycast, IPv6 address. Don't ever forget that. Anycast is completely new in IPv6. Another thing you need to know, and know it very well in IPv6 is, in IPv6, we don't use subnet mask. You will not hear us say the subnet mark is 255. No. We use prefix length. And in IPv4, I've talked about prefix length. Anytime you see /24, /16, /8, those are prefix lengths, which is also pointing to the subnet mask. So when you are talking about IPv6, there is nothing like subnet mask. We use prefix length. That is the way IPv6 works. And I'm going to show you into this class. So what is a prefix length? A prefix length is represented in slash notation, and it is used to indicate the network portion of an IP address. Prefix length is represented in slash notation, and it is used to indicate the network portion of an IP address. So when you say /8, that means the first 8 bits is the network portion. When you say /16, that means the first 16 bits is the network portion. When you say /24, that means the first 24 bits is the network portion. Here we are now with IPv6. Most of the IPv6 address you are going to be seeing now will be /64. That means the first 64 bits, it's our network portion. It's the same concept. The first 64 bit of your IPv6 address is our network portion. Don't forget all the address is 128. We took care of that in our last class. The IPv6 prefix length can range from 0 to 128. We've done that. The recommended IPv6 prefix length for LANs and most other type of network is /64. So most of the IPv6 addresses you'll be seeing, if I give you an assignment or there's any lab you're going to see, is going to be /64. That means the first 64 bit is our network portion. Look at a good example in this place now. And that network portion part, they call it prefix. The other side, they call it interface ID. So they don't call it network portion, host portion, but it's the same thing. Here, it's called prefix. That's our network portion. The other side is called interface ID. Prefix, interface ID. And you can see a very good example here. They give us one example here. 2001 : if you take a look at this now, that is 16 bits. The next one 16 bits. The next one 16 bits. Now that you have : of course, you know the meaning of that. So the first 64 bits of this IP address, which is going to be 2001 : DB8, and you know that this should be 0DB8. Let's just expand it. : A, which will be 00A, 00A. That is 1, 2, 3. Then the last one : 000. Then of course 000 will continue. So the 464 bit of this IP address is our prefix portion, or we call it a network portion in IPv6. Look at what I'm trying to do here. They've even expanded it. Look at it here. So this is the part that points to our network portion in this IP address, and this is the part that points to our host portion. And they're telling you it is recommended, strongly recommended, to use a 64-bit interface ID for most networks. Don't go beyond /64. Well, let me tell you something, guys. In IPv6, that it's also subnetting, but we're not going to do subnetting IPv6. Even myself, I have not mastered the subnetting of IPv6. I have not mastered the subnetting of IPv6. So the point we are making is most of the addresses you are going to be working with or you're going to be seeing will also always be /64 everywhere. And so one of the reasons why they are telling you should use /64 is because of something called SLAC, Stateless Address Auto Configuration. Stateless Address Auto Configuration. It uses 64-bit for the interface ID. So what is this SLAC? I have a whole chapter dedicated to SLAC in the next level, which is NA2. Whoa. No, not it's IPv6, but under it I taught SLAC extensively, and I even demonstrated SLAC there. So we'll leave that until we get to that place. So our IPv6 address should always be /64. Don't ever forget that. Here we are again. Types of IPv6 Unicast address. So even the Unicast address, you get different types. Just like when we were talking about IP addresses, we talk about private IP, we talk about public IP. We have similar concept also in IPv6. So look at it here. One of the addresses, the type of address, the IPv6 address you have, one is called global unicast address. They said this is similar to your public IPv4 address. So almost all the IPv6 addresses you're going to be seeing, they are public IPv6 addresses. Public IPv6 addresses, most of them. And they also have the one that is not equivalent to our private, but it is in between. Let me put it that way. So we have another one called, yeah, Mr. Uche, you're welcome. I talked about you. I mentioned it before the class. You're welcome. I hope Madam is doing fine now. So link local address, it's another address you need to know about. So what is this one used for? It is required for every IPv6 enabled device. Take notes. And it is used to communicate with other devices on the same local link. Let me give you an idea of this. I demonstrated it in that particular class that I mentioned. If I drop a router like this, drop another router like this, connect them together, and just go to the interfaces and activate IPv6. I didn't give any IP address, I just say IPv6. They both will generate link local address on their interfaces, and those addresses will be used to communicate without my intervention, without me putting any IP address. You're going to see when we come to that class. So when you talk about IPv6 address, you have global unicast address, which is our public IPv6 address, and you have the link local that cannot go to the internet, but it is still not the private that you know in IPv4. It's not equivalent to the private that you know in IPv4. It is not equivalent to that private that you know. So still talking about this IPv6 unicast address, they have all kinds of IPv6 unicast address. See them here. Global unicast, link local, loopback. I talked about loopback when we were doing, I can't remember the topic, unspecified address, which is the same thing as our loopback. Unique local. Guys, this is the one that is equivalent to our private IP addresses. So you can decide to say you want to set up the network and use unique local addresses to build your own local area network. But the problem with this, the drawback of this is you can never go to the internet. There's no how you ever go to the internet. So you will still have to go back to global unicast address in order for you to go to the internet. So in essence, you won't ever use this. As a matter of fact, I heard that there was a lot of battle on this unique local. Is it this one? There's another one of yeah, is this one unique local? That why should they even allow it in IPv6? Since we have more than enough IPv6 addresses, public IP addresses that people can use anywhere. And guys, let me tell you this. I don't know if I've mentioned this before. One of the reasons why we're moving to IPv6 is because IPv4 is finishing. So by the time we are fully migrated, almost everything will be given IP addresses as long as you are a smart device, smart TV, smart car, smart shoe, smart ball, smart this, smart that, anything smart. You must have an IP address because if you need to have an IP address to connect to the internet. Without an IP address, you cannot connect to the internet. So IPv6 is the way to go. Yes, it's the truth. It's the way to go. IPv6 is the way to go. And that's why we are learning the basics, the rudiments of IPv6, small, before we eventually get there. Anything smart that needs to connect to the internet or to the network needs an IP address. And by the time we get to that level, there's no hiding place for you guys. Because you will have an IP address that can be traced to you. Public IP address, global unicast address, traced to you live and direct. There's nothing in between you. That's why if you watch a movie, fear will catch you. That I will save at all. That's why cybersecurity is really making wave. Because the same way the good guys can track you, the bad guys can also track you. That's another thing entirely. So you also have this unique local address, which is equivalent to your private IP address. So how would you know that an address is unique local? Any address that starts with FC00 all the way to FDFF, you know that those addresses are unique local addresses, which are like your private IP addresses in IP version 4. The disadvantage of this, you can never, ever go out. If it is IPv4, we can implement a technology called NAT. Then we'll translate from our private IP address to public IP address. This cannot work for IP version 6. If you've decided to use this unique local, that means you're going to remain local for the rest of your life. There is no other way out. They didn't give provision for you to go out because now you carry yourself or can go carry unique local, build your local area network. So you are going nowhere. So if you know you need to go out, which has always been the case for us, leave unique local behind. So that is that on that one. But most of our attention will be on the global unicast address. Why? That is what we use. Why? It is routable. When you hear routable, you can go on the internet. So they are trying to further break down global unicast address. That part that we call prefix the other time, they want to break it down further. They want to further break it down for us. So that part, they call a part, okay, let me put it this way. These two parts here is equivalent to that our prefix. So they broke it down again. They broke prefix into two. Under it, we have global routing prefix, and then you have the subnet ID. This global routing prefix is the one that will define your location, your region, maybe your continent, and service provider, and so on and so forth. And the subnet ID will point to your subnet. Thank God you guys know about subnet. So they broke this thing down. They further broke it down for us. But then they are telling us something here that is very important. From this global routing prefix, they have some X text there that they were working with, some bits there they were working with, or that were available there, which is 16 hexadecimal, no, 16 bits rather, 16 bit now. So from those 16 bits, they tamper or they work with 3 bits out of those 16 bits. And by working on those 16 bits, they were able to give us or to arrive to tell us that, okay, guys, from now on or for this generation, you guys will be using from 2000 all the way to 3FFF. Meaning any IP address you're going to be see, IPv6 address you're going to be see will be within the range of these numbers, hexadecimal numbers. You will never, ever see any IP address in this our generation now. It may happen in the next generation because they reserve all that bit for maybe another generation. When they see that this generation we have exhausted this IP address, or we are not able to exhaust, another generation are not able to exhaust, any generation that finish exhausting these IP addresses, then they will move to another set of bits and alter them again in order to gain ranges of addresses for them. So when I used to teach IPv6 before, I used to tell people that IPv6 must always start with the 200 colon until when I was going to demonstrate, and then one of the sites replied with 3 dots. I have to go back to the drawing board and see what's going on here. That was when I pay attention to this place. So guys, all IPv6 addresses you're going to be see for now will not pass between 200 all the way to 3FFF. You will never see any IPv6 address that start with 4. You will never see any IPv6 address that start with 5 or 6 or 7 or 8. This is for our generation and maybe beyond. So they are just taking care of that first 16 bits, the first 16 bits of our IP address. That is what they will be using to allocate to different countries, different regions, different companies, and so on and so forth. When we are done exhausting this, then they will move to the next level. And I don't think it is going to be easy for us to exhaust these addresses, because from what they said about IPv6 addresses, they said, I think every person on earth will have access to how many thousands of IPv6 addresses. Imagine you in your house now. They just fetch it in like sand and just pack and brought them and just give them to you. Meaning anything you have in your house that need to connect, you have more than enough IPv6 addresses. So if you're having like less than 100,000, another person is having 100,000. How many gadgets do you have in your house? Even if you need to connect all your clothes to the internet, you don't have up to 100,000 clothes. All the gadgets, you don't have up to 100,000 gadgets. So we have more than enough IPv6 addresses. And the reason why they did it this way is because they learned their lesson from IPv4. They didn't see the explosion that took place on the internet now with Internet of Things and the rest. So they learned their lesson. So they cannot afford another kind of mistake to happen. So when they came up with IPv6, they created enough room that in the next, maybe the next century, we still have IPv6 addresses. So they're taking care of century upon century upon century upon century upon century. Even things, technology that is not yet out of internet yet, that may come up tomorrow that will be drinking IP addresses like water. They've taken care of all of those things with IPv6. So take notes. Let's go and see some of those our websites and see what they will reply with. Maybe any one of them will reply with thank you. So ping www.google.com. You see, Google is replying with 201. Look at the 416 bits. 201. What about Facebook? Ping www.facebook.com. Facebook is replying with 2803. Let's try Instagram. Ping Instagram. Instagram.com. Instagram, okay, it belongs to Google, Facebook. See, this 2803. Let me think about another website that is not attached to Facebook. Let's say ping Amazon. Amazon.com. Oh, Amazon is replying with IPv4. Let me see if I can force Amazon to reply with IPv6. Ping the 6 Amazon.com. Ping www. Ping the 6. Yeah, so I have forced Amazon to reply with one of their IPv6 server. Look at the beginning of this IPv6 address, 2600. So you are not going to ever see anything beyond that range that I gave to you guys. It will never be out of that range. The IPv6 addresses you're going to see will always be within that range. 200 all the way to 3FF. There was one that replied with FFF one time. Let me think. Let's think ping www.cnn.com. Okay, look at CNN. It's replying with 2A04. That is the first 16 bit. So and so on and so. You will never see any IPv6 address now that will be outside of that range. Take note of that, guys. Take note of that. Okay, I've just explained this. The global routing prefix, the subnet ID, thank you. Then the interface ID is the same thing we said before. And I'll also talk about link local address. They automatically generate this between themselves, and then they can use that to talk to themselves. Well, we can say, nope, even though you have that, we don't want you to use it. We still go and put our own global unicast address, because this address cannot be routed. It's just locally significant. Link local address is locally significant. The router can use this to talk between themselves. The router can use this to talk to the computer. It's locally significant. And this is another area where, what is it called? IPv6 is completely different. Look at, how do you know a link local address? Whenever you see FE80, let's check my computer. My computer has IPv6 address. So I'll say IP config /all. ipconfig/all. So where is my link local address? FE80, look at it here. Look at my link local address here. Nobody gave my computer this IPv6 address. It automatically generated it. Once you say IPv6 should be activated on that interface, it will automatically generate. And look at my temporary, or let me not use that temporary for now. Let me just go straight to this one. Look at my IPv6 address. So my computer here that I'm using has an IPv4 address and also has an IPv6 address. This is a very good example of dual stack. If I like, this computer can be using IPv6 to be talking, to be going out, to be coming in. People can reach it, I can reach people out. They can use that to reference me. It's a very good example of the dual stack that I spoke about when we started this journey. So why is my computer getting IPv6 address? Because I have, or let me say my computer is automatically activated to get an IPv6 address, just the same way it has been automatically activated to get an IPv4 address. Let's check it out. Let's go to our control panel. Let's go to control panel and see this. So you should know how to check this. You go to your control panel, the network and the internet, network and sharing center. Then you go to your change adapter setting. You look at my card here. This is my Wi-Fi. You right click this. You come to properties. Then look at our IPv4. If I select IPv4 right now and come to properties, what did you see here? Obtain an IP address automatically. And also obtain DNS server address automatically. This is what you see in any Windows operating system. By default. You are the one that can now change it and say, no, I'm giving you an IP address. You click use the following IP address. I don't want to tamper with them because I will lose my connection. So I have my computer has been selected with obtain an IP address automatically. That is there by default. That is for IPv4. If I scroll down here, you're going to see IPv6 is also activated. Click IP version 6. Look at it here. Go to properties. You can see obtain an IPv6 address automatically. Obtain DNS server address automatically. So all of these addresses that we're telling the computer to go and get, where will it get it from? There is a DHCP server somewhere that is dishing out these IP addresses. A DHCP server. I've mentioned this before. Dynamic Host Configuration Protocol server. It's a server that dishes out IP addresses. That server must have been configured with pools of addresses. And when computers, the clients now come and say, I am looking for an IP address, the server will give an IP address out. We have a chapter dedicated to that. This is NA2 on DHCP. And we have some labs also on DHCP. So that's how this thing works behind the scene. So the reason why I have IPv4 addresses and ARMY address, and I also have IPv6 address because there is a DHCP server working. And in my own case, it's my Starlink router. That router has been configured to dish out IP address to me and anybody that connects to me in my house. That's why we are browsing. If the router is not doing that, we have to give those computers IP addressing, my computer IP address manually. If the router is not doing that, I have to do that manually. But because the router is doing that, I don't have to do that manually. I don't want to tamper with the 4. I say use the following IPv6 address. So I will put IPv6 address here. Look at it here. Put the prefix length here. And I'll put the default gateway here. And then if I have any good DNS server that is available, I'll put the DNS server and I will say OK. but I don't want to do that. So I will still leave these settings on. Go and get IPv6 address from any DHCP server you can find out there. This is how this is worked behind the scene. So the only reason why my computer has IPv6 address is because it's been configured to look for IPv6 address. And incidentally, there is a server that is also dishing out this IPv6 address. That's why I have the IPv6 address. I think that is where we draw the curtain. So you can see a good example here, just like I showed you in my own hand. They put an IPv6 address here. You can see they put the slash notation, the prefix length, and then they put the gateway. It's as simple as ABC. That is if you want to do static. Then we don't do static most of the time. We do automatic. That is dynamic. So this I am supposed to have finished this in our last class, but because the class I had to stop the class untimely. That's why I couldn't do that. So any question?